Looks like a lot of people gave up. Okay, let's have a look at it. So they're both 100 meters away, and I think in my explanation I gave you a minute ago, how fast did I say this one was going? 10. Okay, so this is going 10 meters per second, and this one here was going 30 meters per second. And here's the origin. So for this car here, let's just call this one A and this one B. Or A, first car. First we put in its point where it's at. So that is 0 and minus 100. And then we do plus t times its direction, and it's heading 10 meters per second north. So that would be 0, 10. So if you put that all together, you get 0 minus 100 plus 10t. So if you think about it, when t is 0, the car is at 0 minus 100. When the t is 1, the car is at 0 minus 90. The t is 2, it's at 0 minus 80. So for example here, how long until it reaches the crossroads? 10 seconds, yeah. We can do the same thing for car B. It would be 100, 0 plus t times minus 30, 0. So that would be 100 minus 30t times 0. So again, when t is 0, you can see it's 100 meters away. When t is 1, you can see it's 70 meters away. 70, 0. When t is 2, you can see that it's at 40, 0. So these two vectors represent where the car is. And that's why it was okay to say that these are the same, because they represent the same thing in both cases. This t here is actually representing the time. And time is the same for both. So it was okay for us to say t for both. Okay, I think I'll do this using vectors. So I'd like the vector from A to B. So that's or AB. Or if you don't like the or there, I can just call it A and B. So AB, that's B minus A. So that's B minus 0, and then 0 minus that one. So the magnitude of it would equal the magnitude of this. So the magnitude squared would equal the magnitude squared of this, which would equal square root 100 minus 30t squared plus 100 minus 10t squared. With a square as well, because of the square here. So if I clean that up a little bit, if I squared this, I'd get 10,000 minus 60,100 plus 900t squared plus 10,000 minus 20,100. Sorry, do I have too many zeros there? I think I do. I should have 3 zeros here, and I should have 3, yeah. T plus 100t squared.
What if I said with the card being moved with the positive person, if it moves to the left side?
car B moves with,
from left to right, so instead of the
yeah, but I think in the question, I sure hope I said in the question they're heading to the crossroads. If I'm not, it should be in the question.
cars are 100 meters from the crossroads.
Yeah. But do I say they're heading to the crossroads? Okay. Yeah, I really want them heading to the crossroads, because if the other one was positive 30, then the distance just keeps getting bigger and bigger.
No, it says going from left to right.
Oh, I see, if you put on the other side heading towards it, yeah, that's fine, and you get the same answer.
Yeah, but the section would be positive, so the equation would be different. No?
It'd be different, right, but the point would be minus 100, so it'll fix itself in the end, yeah. And in fact, you could have swapped the cars as well. You could have put 30 at the bottom and 10 on the right. You'll get the same answer either way. As long as you have the two of them heading to the crossroads, it doesn't matter which way around you draw them. Well, of course, if you put the B car here, then the distance will be 0 because they'll crash. So, except that one maybe. Okay. So here, this is, let me see, 10,000 and 10,000. At the end?
No.
Oh, sorry, I left out a T here, yeah. Thank you. 10,000 and 10,000 is 20,000. Minus 6,000 minus 2,000 is minus 8,000 plus 10,000 T squared. Although that looks very big, because of all the zeros in it, it will simplify a lot. So let me just call that L, meaning length. So the derivative here will be minus 8,000 T plus 2,000, oh sorry, there's no T there, just minus 8,000 plus 2,000 T equals 0. So therefore, T equals 4. So after 4 seconds, there would be the closest they'll be together. So I'm sure part 1 is asking you to find the time, and part 2 is probably asking you what is the closest distance, is it? Yeah. So I'll just take this answer and put it back in here, but without the square. I would like the distance. So the answer is distance equals, so there will be a square root, and it will be 100 minus 120. Do I have an answer? Well, yeah, I could put it in here and then square root it. Yeah. Well, I'll just put it back in here. 100 minus 120 squared plus 100 minus 40 squared. So that would equal square root of 20 squared, which is 400, and then 60 squared, which is 3. Sorry, I better not do too much in my head. This is 20 squared, and then this is 60 squared. 400, 3600. That's square root 4000. I don't know what that is. Can someone check it, please? It's not 20 root 10. Yeah.
You see the first time up top?
This one?
Yeah, you squared both sides
Yeah.
in order to remove the
Square root, yeah.
But doesn't that affect the magnitude?
It does, you're right. But if you remember last time, it affects the magnitude, but it doesn't affect the time, because, don't worry, I'll go back to this in a second. If I say here's car A, here's car B, and here's, after 1 second, well, hang on. T is 0, 1, 2, and this is the distance between the cars. So let's say they're 5 meters apart, then they're 2 meters apart, then they're 10 meters apart. So at what time are they closest together? 1 second. Now suppose I look at the magnitude squared, 25 for 100, and forget about this. When are they closest together? When is it minimum?
1.
Still at the same time, isn't it? So by squaring the magnitude, you don't change the answer for time. But of course, you know that this is not the distance, it's actually this one here. So as Carl was suggesting as well earlier, what you could do is take your answer and put it back in, and then after that square root it. Or what I did was put my answer in before I squared it, like leaving the square root there. Both are fine. Okay, I'll let you try another one that's a bit like this. Let's see which one. Why don't you try number 4? I'll give you a little hint for number 4. If we look here, imagine this ground is the I, and then the height is J. Give me a vector that would represent something pointing along the ground. Yeah? So for example, the vector 1, 1, that would be going 1 across and 1 up, so that would be a vector pointing like here. Yeah? So give me a vector that just points on the ground.
This is J.
No, this is I, and then the height is J. 1, 0. Wouldn't that be a vector that points on the ground? Yeah? So like, here, I'll draw it here. Imagine that this is the ground here. So I want a vector that points on the ground. It points along the direction of the ground. So if this is I, what could this be? Well, you could use like 1, 0, couldn't you? Because what would this vector here be? That would be 0, 1. And for example, what's this vector here? Maybe that's like 1, 1. So in other words, this is the vector, this is a vector that points on the ground. Now the reason I'm telling you this is, imagine I give you this vector here, or, and I want to know the angle it makes with the ground. Then I need to have another vector that's on the ground. Because we have a formula to find the angle between two vectors, don't we? What formula is that? The cos theta one, isn't it? So if I ask you to find the angle a vector makes with the ground, then you need to pick any vector that's on the ground. So in fact, if you use 1, 0, or if someone besides you uses 2, 0, you'll get the same answer, because they're both vectors on the ground. You can see that the angle is the same even if I use 1, 0, or what about if I use 2, 0? Is that the same angle? It is, yeah. So keep this in mind when you try number 4 now. Okay, have a look at number 4. I'll go back up to the number 1 here. I don't think you need to consider the z because I don't use a z at all in my vector number 4. Do I just think it has an I and a j?
Just and J.
Yeah. Okay, some people have it done. Yeah, so let's have a look at it. So what's my vector I give you for or?
3t.
Yeah, for the I. And then the j?
4t minus 5t squared.
14 minus 5t squared. That's the or vector. Then in red, let's put in the ground. So here's the vector on the ground. Let's just call that G. Huh? You want to go for 2? Alright, 2, 0. And we want to find this angle here, the cos of this angle. So we have a formula for this. Cos theta equals or dot G over magnitude or times magnitude G. So that would be 6t plus 0 all over square root and then square root. So square root this one here, that's 3t squared plus 4t minus 5t squared, and then the g is 4 plus 0. So that would be 6t, square root of 4 is just 2, so that's handy. Now, I need to square out this.
Do we need to simplify it?
I would, because I want to show that I'll get the same answer all the time. Like, I'm sure some people didn't use 2 here. I'm sure some people used 1. But if we both simplify, we both should end up with the same answer, okay? So, let's have a look. 9t squared plus 16t squared minus 40t cubed plus 25t4. Now, on the top there's a 6t and there's a 2 here, so I can cancel that 3t. And that's good, because that shows us, if I just go for a moment, how did I get this 6 here? It was multiplying the 2 with the 3. And then, how did I get this 2 here? That's this 2 here. Square root of 2 squared. In other words, you can see that if you put 3, 4, 5 or 6 here, what's going to happen is you'll always have something that will cancel with this to bring it back to 3. So a lot of people probably just had 3t from the beginning. Yeah. So this is square root 25t4 minus 40t cubed plus 25 t squared. You can see that there's a t squared in everything. I can take that out. T squared 25. Oh, it's actually a 5, but yeah, I'll take the 5 out as well. 5. So that would be 5t squared minus 8t plus 5. So that would be 3t all over square root 5 times t times square root 5t squared minus 8t plus 5. So that t cancels with that. And does this have factors down here? I don't know. 3 over square root 5 square root, let's see if it has factors.
Yeah.
5t t none.
1
I don't think so. 64.
1 and 0.6.
don't think it has factors, does it? No. No, I don't think it has any factors. I don't even think it has roots. Let's see. Discriminant is b squared minus 4 times 25. No, that's negative. It doesn't even have any roots, so it definitely won't have factors. So the answer is 3 over root 5 root 5t squared minus 8t plus 5 cos theta. So you can put in any value of t and you can get the angle. So let me just go back, if I just go back to my equation, 3t, okay. Can you just read it back to me? What is it? 3t and
40t minus 5t squared.
Okay. So let's put t equals 0. Well, t equals 0 doesn't really make sense. By the way, you've noticed that this step here, I cancelled the t's. I can only do that if t is not 0. So we'll just forget about 0 for the moment. If I put t equals 1, what vector do I get? 3 and minus 1. So that would look like this, 3 and minus 1. So that would be t equals 1. And then if I put t equals 2, what do I get? 6 and minus 12. So that would be some vector like this, wouldn't it? T equals 2. So you see that when I put in different t's, I get different vectors, and of course, I'll get different angles as well. So what's happening to the angle here? It's increasing, isn't it? Well, it's getting more and more negative with respect to the ground. Let's just do one more. If I put t equals 3, what will I get? I'll get 9 and then 4 minus 15. Isn't it? 4 minus 15. Minus 11? No? Sorry, 4 minus 5 times 3. 4 minus...
33.
Oh, sorry, it's 3 squared.
33.
So it's really large, and this one here...
Minus 33.
Yeah. 9 and minus 33. In other words, it would be really far down, like down here. Like that. Okay. So that's that angle there. So if you needed to find any of these angles, you can just put the t in. So let's just, for one example, put in the first angle here. So that would be cos, let me call it theta 1. That would be 3 over root 5, let's see, that's 5 plus 5 is 10, minus 8 is 2 actually. So can someone tell me what the first angle here is? Now if it's positive, that's fine.
0.999.
You're in radians or degrees?
18 degrees.
Oh, okay, so it's actually really small then. 0.
Oh wait, sorry. I thought it was 18.
18 degrees, okay. 18 degrees, yeah. That's up there. Although it does, yeah, it does make 18 degrees with the y-axis, that's true, but I suppose the only problem with this formula is it can't tell you if it's above or below, because if you look at the formula, when can this formula, see these two here are both positive, you know. But anyway, we're getting into a point that's not important here. it will give me the angle between the two vectors, but it won't give it to me as a plus or a minus. It won't say, for example, oh, it's 18 like this instead of 18 like this. The formula just tells me they're 18 apart. So I need some kind of diagram if I want to see how exactly. This is a little bit different to what we did in coordinate geometry, because you know if it was a minus answer, it means it's below the x-axis. Remember, like, this is 0, this is 10, and this will be, minus 10. This isn't true with vectors, because with the vectors, you can put your vector anywhere. You can get the angle between this vector and this vector. So plus and minus doesn't really make sense, because it could be anywhere you want. So 18 is the answer, but I know from my diagram, it's 18 underneath the y-axis. Okay? So don't worry about the sign. I wasn't really supposed to get minus there anyway. This is how, it's a little bit different to the coordinate geometry angles. Okay? Alright. Like I said, in the exam, they haven't asked it, but I need to do it in case they ask it because it's in the syllabus. It should not be in section A, it should only be in section B. Although, I don't know, maybe you'll get unlucky and it'll be in section A. Okay, so I think that you should have enough time to try one of them before we go, so let's see what would be a good one to try. I think you should try number 3, and I really would encourage you to use derivatives to calculate the shortest distance in number 3, because I feel like it's a little, like in my example with the cars, it's a little bit easier. Okay, so do number 3 like number 1. In fact, number 3 is easier because there's only one t in it for the first object. The second object isn't moving. So number 3, try that please. But the T, that's okay. It would actually mean that the shortest distance happened earlier. T can, just so you know, T can be any number, positive, negative, or zero. There's no restriction on it. Yes. About this one? What's the problem with it? Which one am I looking at? Here, good, 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 good. Yeah, good. And now, the derivative of this equals 0 is what you need to do next, because you want to make this a minimum.
What's the minimum? Is it the distance or the t?
You want to make this ab squared a minimum. This is a bit like the y, and the t is a bit like the x. So you want to find the x that makes y a minimum, if you want to think about it that way.
What represents the distance here?
The square root of this.
So, this is AB.
The ab, yeah. Yeah.
And the t represents?
It's just a variable. In this case, it represents time, but it just represents all the different vectors as the spaceship is moving. But it's just a variable that draws the path, you know. Remember, we said like if t goes to minus infinity, it goes down, and then when t goes to infinity, it goes along the line, and then when t equals 0, the point on the line, yeah, the starting point. If there's time, I can do this one in the tutorial. But I think the proofs will probably take up a lot of the time. But I think I might have some time to do it if you can't get it. Yes. Okay, well I'll do it later in the tutorial now. So that's okay, I'll do it in the tutorial. Do I have the time for this? Then you have to put that in. Oh, okay, what's the answer to that? That's not that? Off by much? It's not quite acceptable. I'll do it later then. He got 14.6. What did you get? Alright, I'll find you in the tutorial later. So. If I have time after I do those proof questions, I'll do this one in the tutorial next day. Before you go, you know you have your test tomorrow. Yeah? So it'll be a 2-hour test like the final exam. I know we haven't done statistics yet, but I'll include it on the exam as an optional question. So you can choose to do it if you know how to do it. Okay, but you won't lose any marks if you don't do it. It's just an optional question. Yes? Question?
Yeah.
Oh, yeah.
No.
What?
New idea.
New idea, go ahead.
We have extra math classes this week because we're facing what we lost last week, right?
Yeah.
So let's take advantage and finish the maths this week, then have a practice then next week when we're all fully ready.
That's a really good idea. Let's not do that though. No. The 2 extra classes, I was going to have to do the test anyway. Those 2 extra classes can be for the test. There's still 4 classes left this week, isn't there? Or 3? We'll probably get the statistics finished by the end of next week, or Monday, the following week at the latest. There's 5 weeks left, isn't there? 4 weeks left or 5? Is it 4? 5. I thought it was 5. Including this one, yeah. So there should be 4, or at least 3.5 weeks of revision, possibly 4. Maybe we can do 2 of the statistics in 1 lesson if we need to. But if we have 4 weeks of revision, that's really good. Yeah. So the test is tomorrow. Okay? It'll look like the final exam. There'll be a section A, section B, 2 hours. Answer all of section A, except the statistics, that's optional, and 4 from section B. And you can choose to do the statistics question if you know how to do it, because it is easy, but we haven't done it yet. Yeah? Any questions about the test? No. Okay. Don't be late. Right, Charles? Alright. See you later today.